My name is Alex Kazera, and for my project, I'll be giving a presentation on encryption in MySQL, the options that you have, and how to use them. First of all, encryption is very important in any database. It is defined as the process of taking plain text that you want to hide and making it unreadable to all except those with access to a key or password. This is very useful in database security, as you almost always have information in your database that you do not want everyone to have access to. Common examples of this data are passwords, digital signatures, and financial data. With encryption, you can guarantee that the only people that will have access to this information are people that have the knowledge of your own unique key. In MySQL, as in most databases, there are two different encryption techniques. First of all, there's two-way encryption. This technique allows for both encryption and decryption. With that, you can undo any encryption that you place on data, enabling you to again view or alter that data. The second technique is one-way encryption. This process is not able to be undone, and therefore you cannot re-access and change the data. For this reason, the one-way technique is used mostly in password creation or in dealing with digital signatures. There are many different encryption functions within these two techniques in MySQL. Chapter 11 of the MySQL Reference Manual explains each of these and how they can be implemented into your database. The MD5, SHA1, and encrypt functions stand as the one-way encryption techniques, while the AES and DES functions are the two-way techniques. Each of the three one-way encryption functions work in a similar way, so I'll focus solely on the MD5 command. MD5 encryption uses a hash function to encrypt an arbitrary length plaintext message. Hash functions are cryptographic functions that take in plaintext and output a fixed size bit string. The MD5 algorithm works by first padding a plaintext message. The message is then manipulated in 128-bit states. These states are divided into 32-bit words, which go through 4 rounds of being modified. These rounds each consist of 16 operations based on modular addition to encrypt the data. The algorithm then outputs a 128-bit fingerprint that is an encrypted version of the original plaintext. MD5 is easy to use in MySQL, as you can encrypt any data simply with one insert command. In this case, the password guessme becomes encrypted in MySQL, and the output from the first select statement is the fingerprint created by the MD5 hash function. Since it is a one-way encryption technique, you cannot undo the encryption to manipulate the password, but you can use the encrypted plaintext to display other attributes by using a simple select statement as shown here. Moving on to the two-way encryption in MySQL, we must first look at the DES function. DES was created in 1977 as a block cipher algorithm of encryption. This means that it encrypts plain text by dividing the text into certain sized data blocks and encrypting each individually. The DES algorithm uses a 56-bit key to encrypt a 64-bit block of data. To do this, it uses permutation tables to encrypt both the plain text and the key. Then it puts each block of encrypted plaintext through 16 rounds of permutation transformations before it outputs a ciphertext representation of the plaintext input. To use the DES encrypt function, you need both a crypt string and a key string. The first is the string that you want to be encrypted, and the second is the key that you want to use to encrypt it. In this case, you can see that my encrypted string is my password, and my key is sample key. Using these in the DES function produces an encrypted version of the myPassword string as shown in the first select statement. This encrypted version can only be decrypted with the knowledge of the key and then can be displayed in the select statement at the bottom of the slide. But the safest encryption technique available in MySQL is the AES encryption function. This also uses a block cipher algorithm but uses a key much larger than DES and therefore is safer. AES algorithm uses a key of either 128, 192, or 256 bits to encrypt a block of data. The algorithm splits the data into 4x4 arrays of bytes to encrypt. These arrays are put through 4 transformation steps that are repeated a number of times. These steps are subbytes, shift rows, mix columns, and add round key. Each of these steps uses substitutions and permutations to encrypt the block of data. After these steps are repeated a set number of times, the ciphertext is returned and the input data is fully encrypted. In MySQL, this function is used in a very similar way to DES encrypt. You again need both a crypt string and a key string. In this case, you can see that my encrypted string is my password and my key is sample key, just as in the DES encrypt example. Using these, in the function produces an encrypted version of the my password string, which is shown in the first select statement on this slide. The second select statement shows the way to decrypt the my password string, which can only be done with the knowledge of the key and then shown in this select statement. And these are the options for encryption in MySQL, and that's my presentation. Thank you.